So good morning, lads. As I promised you today, we're going to do 2 experiments, or even 3, to demonstrate 2 aspects of gases, 2 characteristics of gases or air. Sometimes in an exam they can talk about air when they refer to gases. So gases and air mean the same. So we are going to do at least 3 experiments to show that gases have the characteristics that we said. And in our first experiment, learner, we are going to have an experiment to be able to demonstrate that gases have mass. Now, I want the learner to have 2 small balls. You know the balls that you use back at home for playing. After getting the 2 balls, inflate them. Put air inside using your mouth. Of the same, let the balls be of the same size. If you can't use your mouth, then you can have a palm. The small balls that you use can be inflated using your mouth. Inflate them and ensure that they have the same amount of air inside. Then, this is how you balance them. You put them on something like this. So when you inflate them, you place them on a stand like this. That is a stand. That is a stand. So on one side you tie a string. Place your ball inside here. That is your ball inside there, that stand. Then on the other side you still have the same like a bag, a small bag that can carry your ball like this. Then you ensure that you balance from the center. That is my center, and I balance it so nicely so that it doesn't fall down. You have your stand there. So that is a stand. So I want you to see how this one balances so well when it's like that. But now I want you to do up another experiment, that is experiment A. So in this case, what are you going to observe? You're going to realize that if you balance, if the balls are the same size and place them on a balance here, remember this is rotating. It can rotate this way or the other way because it's tied here using a nail. It's tied using a nail. So it can rotate either way. So if you inflate the same 2 balls with the same amount of air and place them on a basket like this, and you hang them from the same, look at this point, from the same distance, you hang them from the same distance there. They are going to balance. But again, I want you to do this. The same balls, bring them back here. You have this a bar there. Your bar is still there. Your stand is there. Balance them again. So you realize that this one, tell you what to do with those balls. The same 2 balls, I want you to remove air from one of the balls. This one here, remove air. So if you remove air and you try to balance using the same stand, this is what happens. You will see the one that is not having air coming down. Meaning that if it's coming down, it's supposed to be the other way around. Supposed to be the other way around. So this is the one without air. So the one without air goes up. Deflated ball. This one has air. So this ball, the ones that has air inside, is going to pull the one that doesn't have air because it has become light. Meaning that the mass of this particular ball, and then it doesn't look like this. In this case, when it doesn't have air, it looks like that. Look at this, deflated. It doesn't have air again. So it's going to be lifted by the one that is heavy. So this one is heavier compared to this, meaning that this has mass. Mass is the weight of an object. So this is more heavier compared to this one. So this becomes light. And that's why you see it being lifted up. I know you have done the seesaw. You know what the seesaw means? Yes, I know you know because you are doing it even at home. One person sits here. That is person A, person B here. If this person is heavier compared to this one, if this one is light, you will see the seesaw doing like this. That is the seesaw. The seesaw is going to look like this. Assuming this person is having 20 kilograms and this one is having 15 kilograms. That's how they look like. The one who is heavier is going to lift the one who is light. So that's how it happens. Meaning that gases have mass, they have weight. That's why a ball like this is going to lift the one that doesn't have air. So that is a simple example that can, or activity that can be able to do at home. I want to give you a second example of an activity. I want you to have two balloons. You have two balloons, and then those two balloons you have your hanger here, the one that you use for clothes. Hang them with the balloon. Inflate them. Inflate them. You have two balloons there. Inflate them with the same size. The same size. Put air inside the two balloons and hang them on the sides of the hanger. So this is the hanger. The arm is suspended from a side here, from somewhere there. So it's suspended there. And you look at that experiment A. So the two balloons are inflated and placed there. You can see what they are doing. They are balancing. They are on a balance. No one is lifting the other one. But the same balloons, you bring them down here. And then want to have this. Your two balloons again are there. Then you prick this one. What is to prick? Use a pin. And because it's having air inside, you prick it. And this is what happens. If you prick it, the one pricked looks like this. Then the other one is not pricked. You prick on one, prick one, this one looks like this. I want you to look at this line. Look at those balloons. After one is pricked, means that you have removed the air. The pricked balloon. Pricked balloon. Meaning that the air is gone. So it becomes lighter. It becomes lighter. So that's why this one is lifting the other one up. These two experiments I've just explained here confirm to us that gases or air have mass, they have weight, they are heavier. When a ball is having air and a ball that is having air, the one that is having air looks heavier compared to the one that is having, the one that has air looks heavier than the one that doesn't have air. That confirms to us that gases have mass. Gases have mass. The last experiment I want us to do is an experiment to confirm that I'll do one, then later next time I'll do another one. That gases have occupy space. Gases occupy space. Gases occupy space. So I'm going to draw an experiment here, an illustration, to illustrate that gases occupy spaces. Gases occupy space. gases occupy space. I'm going to do one experiment, then I'm going to do the next experiment for you to be able to do. So this is what will happen. If you want to investigate whether gases occupy space, you will have something like this. Something like a glass. You have a glass, then this is a basin of water. That is a jar of water, the first experiment. So we have water here. So what you do to be able to get this learner, I'm going to draw experiment A and then B. This is a glass, empty glass. Empty glass. And number 2, container. Then we'll have some clear water. Clear water. The next experiment is going to be the same experiment. But this time around, I want you to see how I'm going to draw the next experiment. I want you to pick a glass. We have some water inside the glass. But the water does not enter up to where we are, the bottom of the glass. Doesn't fill the glass. There's a reason why the water doesn't enter and fill the glass here. So we have the next experiment, of course, the same experiment. A glass. I'm going to have a glass, then you're going to see bubbles here. I want you to look how I've drawn that glass. So what happens in our first experiment? So this is a container. This is a clear glass. Bubbles. And then we have water. Clear water. In our experiment number 1, you have your water in a basin, and then you pick a glass, and place it inside the water directly, upright. Don't twist the glass. Just upright like this, straight, and place it inside the glass. So what are the observations that you are going to make? So the observation you make is that here, in this space, there will be no water in the glass. Water will not enter the glass. Then come to the second experiment. You realize that you will find that after you twist this glass a bit to allow a space here, to allow a space where there is, between the container at the bottom and the glass, you allow a small space here. You will see bubbles coming through that space, meaning that inside this glass there was air, and because you have allowed a way for this air to come out, that's why you see air coming out. And as the air comes out, you will see water rising in the glass. So the water will rise until it will fill the glass as the air gets out. Meaning that the air has to go out for the water to come inside and fill the glass. That means that the water that is coming to fill in the glass is coming to occupy the space that has been left by the air that is coming out as bubbles. And that's also, you realize that the water that is going to be in the basin here, or the container, is going to reduce inside in height, meaning that much of the water is getting into the glass, and so here in the basin, none is going to be left there. Very little is going to remain there, meaning that this water is going in to occupy the space that has been left by this gas, which is air, coming out of the glass. In this first experiment, the water could not enter the glass because there was air inside that had occupied that space. But as we tilt the glass, you will see the air coming out and the water entering the glass to fill the glass. That confirms to us that air or gases occupies space. They have occupied this space. Once we release it out, the water now comes to occupy the space that is occupied by air. So those are the two experiments that I wanted us to do today. There is one remaining, and that one that has remained I'll give you as homework back at home, so that you'll be able to do it at home, and then you give me your findings. What exactly did you notice after doing the experiment? So until next time, learner, I want to wish you well, and may God continue